Hey there, it's Jason with a short video diary bonus, a bonus video diary entry this Easter weekend. I wanted to talk a little bit about test-driven development and design discovery or emergent design. So the idea of TDD essentially is that we're using tests to lead us to the simplest design, the best design that will solve the customer's problem. So it should all be about those outcomes that our users want. And it's a process of discovering the design through writing tests and through refactoring. But what can often go wrong is people come into it with preconceived ideas about what design they want to write. And rather than writing tests and then coming up with the simplest design that will pass those tests, they're writing tests that are about the design that they want to implement. I call it design-driven testing. And that often leads us to unnecessary generality and complexity. But often it also leads us to designs that don't actually work, that don't actually fulfill those outcomes that the users want. Keith Braithwaite came up with a really great exercise called TDD as if you meant it, to sort of exercise those design discovery muscles. And the way the exercise works is that you write the code to pass the test inside the test. So you don't declare classes and methods, etc., or any part of your design. You just write the code that does the work that passes the test inside the test, and then you refactor to reveal the design afterwards. And this is a good exercise in design discovery. So we're going to be doing an object-oriented sort of version of this to illustrate what I mean by that. And I'll post a link to Keith's blog post about TDD as if you meant it. So you can have a go at this yourself. But it's even if you don't actually work this way normally, I don't. It's actually really good exercise. It's actually really good practice for sort of stretching those refactoring muscles and for coming up with designs based on what will be the simplest code, the best code, the cleanest code that will pass your tests. So I've got a simple example here. So this is some code that I've written, in that as if you meant it style, to calculate quotes for fitted carpets. And as you can see, the code that actually calculates the quote is inside the test. So in our setup, we've got the raw data. We've got a price per square meter for our carpet, and we've got the room width and the room length. And then we do the calculation in the body of the test. So I've not declared any classes or methods in my solution yet. And what I'm going to do is I'm going to refactor this code, and we'll see what kind of design emerges and see what we think of it. This is object-oriented, so it's going to take us down that road because we're working in Java. So first of all, the code that does the work really belongs in its own place. So I'm going to extract a method. Let's call it get quote, not so keen on that. Calculate. I'm just going to call it quote, actually. Quote can be a verb. Okay. Of course, I immediately rerun my test. So we've introduced this quote method, and this now does the work. And it kind of comes with all the data that it requires to do that work. Let's just inline that. We don't need that anymore. And so far, so good. And the next thing is this method doesn't really belong here in the test. The test should be about tests, not about implementations. So what I'm going to do is I want to introduce a new class that's going to have this quote method, and it's going to contain this data. So we're going to encapsulate the data required to generate the quote inside the class that does that work. So let's start with what has a price per square meter. So I'm thinking, let's call it a carpet. So what I'm going to do is I'm going to introduce a parameter object called carpet that has a price per square meter. There you go. Let's not put this in the test code. Let's move this to the source. There we go. And I'm going to call this carpet. So it's a carpet.quote. That sounds good to me. Why am I not taking width and length with me? Because, well, I think those can change. I think the price per square meter will always be true for that carpet, probably. But I think we might want to generate quotes for that carpet for rooms of different dimensions. So because they're transient, I'm going to leave those as parameters of this method so they can change every time we invoke it. We don't have to keep creating a new carpet for different rooms. Okay, so that's an object lifetime question there. So let's refactor that. Looking good. Okay, so there's now this carpet object. It has a price per square meter. You can see the getter for it there. And really, this quote method belongs to the carpet. So the next thing I'm going to do after my tests are passed is I'm going to move this instance method to this new class. So let's do a move. Okay, and now there you go. Carpet has the quote method, carpet.quote. So through this process of refactoring, we've introduced this carpet class to do the work. We've given it the price per square meter, and we've given it that quote method for rooms of different dimensions. Okay, note that we no longer need this getter because it's doing the work itself. Nobody else needs to reference this, so I'm going to inline that and get rid of it. And then we can encapsulate that information. Nobody needs to know how the carpet is doing its work. And encapsulation is a good thing. And you can only achieve encapsulation by putting the work where the object of that work, the thing to which the work is being done, lives. So put the work and the object, put the work and the data together. Okay. Now, that's so far so good. But this, again, not so sure about this. I'm not so sure that this is about the carpet. I think maybe this is about the room, this part here. So what we're going to do is we're going to try and get this into its own class. And it's kind of similar to what we did before, but now we're going to do it for this method. We're going to introduce a parameter object with a room width and a room length. Okay. So far, so good. Can I rename those? Because I think room is going to become redundant in a minute. No, not room. Width. Still adjacent. And length. We're going to call that room. And that belongs, yeah, that's going in the right place. So similar kind of thing. So I'm using introduce parameter object to discover objects in terms of their data. And then we make a decision about where the code that uses that data really belongs. And in that case, it's this code, this expression here, really. So what I'm going to do is I'm going to move this to its own method. Let's extract a method. Let's call it, I'm just going to call it area. And that takes a room. So similar to what we did with carpet, with the quote method. Keep the original signature, getting a little too clever for ourselves there. And now again, this really doesn't belong here. It's all about the room. So let's move this instance method to room. Okay. And having done that, that means we can encapsulate these fields. We can get rid of the getters. Let's just do them both in one fell swoop. So again, we're hiding the data. Room does the job of calculating the area of the room, and nobody needs to know how it's being done, which is a good thing because it means we can change that without having to change how carpet works. So all still working, a bit more clearing up to do. We can inline that, simplify things a little more. Okay, so very, very simple now. Okay, so that's TDD as if you meant it. That's discovering a design, discovering a carpet class, and discovering a room class, and discovering where those methods belong. Through this process of refactoring, so that we've got the code that does the work. That's always the most important thing. We've got the code that does the work. So all we're really doing is repackaging that code. That's all object-oriented design. OO design is really about how we package code, as is any kind of modular design. It's all about how the code is packaged into methods and classes or functions and modules, deciding where the work belongs. As long as the work still gets done, that's the most important thing. Now, because we're working in Java, there's one final little flourish here. I would like the freedom potentially to handle different shaped rooms. So the way that the area of the room is calculated, we might want to vary that. without having to constantly rewrite carpet. So what I'm going to do, I'm just going to rename this to make it more specific. So let's call that's really a rectangular room. It's got a width and a length. Okay. And no, we don't want to change that. It will always be room. And let's run our tests. And then what I'm going to do is I'm going to extract an interface called room so that we could have different kinds of rooms. So we get proper swappability here. So we solve potential long-term problems. Okay. And it's probably going to prompt me to replace it where it's being used. Let's replace usages. It'll find some. There we go. Let's do the refactoring. So now when we look inside carpet, it only knows about that interface. It's not depending on the implementation of rectangular room. And let's rerun our tests. So through that process of refactoring, through that sort of design discovery exercise, we discovered two classes. And we've introduced an interface and we've introduced dependency injection. But it's still the design that passes the test. And that's the most important thing. This is the design that passes the test. And it's a clean design. So we've got two modules, each of which does one job. The room is swappable by dependency injection. And they're hiding their internal workings. They're hiding their data from their clients. So we're ticking the boxes that we should be ticking for good modular design. So that's TDD as you've implemented. That's the design discovery process of test-driven development. Now, in the real world, it's probably going to be a mix of both. So you'll probably make some design decisions while you're writing the test. I might have decided, for example, to have a carpet object and then through refactoring introduce the room afterwards. So it's a bit like golf. It's not all driving or all putting. It's a combination of the two. So a combination of making design decisions as you're writing the test, and that includes decisions you made up front at a very high level, and refactoring after the fact to discover details of the design that probably you wouldn't have noticed without actually seeing the code. The most important thing, of course, is the code passes the test, and we've got no code that's not required to pass that test. We've just shuffled the code around a bit. To make it more object-oriented. So yeah, that's today's video diary entry. Design discovery, that's what TDD is really supposed to be about. Keith's is a great exercise for sort of exercising those skills and for disciplining yourself to use refactoring as part of the design process. It's a very important part of the design process because there are many sort of detailed decisions that are most effectively made when you actually see the code in front of you. When you try to make those decisions up front, you're kind of guessing. It's like playing a game of chess in your head. It's best to actually see the board, see where the pieces actually are, and then plan ahead. So very important skills. So there you go. That's your bonus video diary entry for this weekend. Hope that's been of some use. Stay safe.